let's go through LeetCode 2467, most profitable paths in a tree. So this question, it gives us two-dimensional array edges, which represent a tree. And at the beginning, there is Bob and Alice. Alice is at the node 0, and we'll say that is we can consider that as root. But for actually, we will see tree, we can consider any node as root, right? So which one is node, it doesn't matter. And Bob is at a node Bob. And it says that for every second, Alice and Bob each move to an adjacent node. And Alice moved towards some leaf nodes. So Alice is at the beginning at this kind of node, and it can have different steps. For example, like can go this path, can go to this path. It will stop until it goes to a node which is leaf. The leaf is that it does not have other childs, right? So for this kind of scenario is that we possibly create a map. And if it has only one child, then that is a leaf node. And it says that Bob is moving towards node 0. So Bob, for example, he is at this node. Then he has one path come to 0, right? And say that for every node along their path, Alice and Bob either spend money to open the gate at the node. So that means, for example, Alice at node 0, then she need to spend -2 money, and say that if Alice and Bob reach the node simultaneously, then they share that price or rewards for the opening gate there. For example, Alice is here, right? And Bob is here. So they both reach to this node 1, in 1 steps. So that means for this kind of money they earn, they will split. So Alice will get 2, and Bob will get 2. And also you say that if Alice reaches a leaf node, and also say that if Alice already goes to node which Bob already opens the gate. For example, this node, right? Bob already use of -4. In this case, if Alice go to this kind of step, because she's after Bob going to this node, this money has been spent by Bob. In this case, Alice will just take a 0. So it asks for all of the paths Alice goes, the maximum net income Alice can have if he travels towards the optimal leaf nodes. So that means that for this question, apparently, if we don't consider Bob, right, it is just a very basic DFS traversal. Then we can, for every path, we try to get the path money and total money in the updated global result. But we have Bob here, and so we need to use Bob, traverse Bob first to get some kind of, for example, we are going to create a map. For example, for this kind of node, right? And the key will be the node Bob visited, for example, 3, right? And the value will be how many steps Bob has used, for example, 3, then that is 0, right? And so we are going to have two DFS. One is traverse from Bob, and we can because Bob has only one route, right? So he stopped at the node 0. So after this DFS, we get a map which has for this path how many steps he spent. And then we do the second traverse is from Alice, right? From the Alice, and for the basic traversal, we need to when Alice visit a node, we try to see how many steps Alice has visited for this node, and also we try to see whether this node is visited by Bob as well. If it is visited by Bob, we compare the steps of Alice used and Bob used. If Alice steps is smaller than Bob's steps, right? Then in this case, that means Alice will take this money. If it equals, then they will split, right? If Alice's steps is greater than this kind of Bob's steps, then Alice will take 0, right? And another case is that Alice visited a node which Bob didn't visit. So for the map we create doesn't contains this key, then also Alice will going to take this money. So just add these constraints, we when Alice visits some kind of leaf nodes, we compare the local net income with a global variable. So let's begin to write code for this. And what we need is that first we need to, from this kind of edges to create a map, right? So we need to have the integer, list of integer. We call map, new hash map. And we are going to iterate the edges. What we're going to do is that map utility absent edge 0. It goes to new array list tag h1, right? And also we need 1 at the edge 0, right? So we compose this graph. And the first thing is that we need to compose our Bob map, right? Yeah. So the key will be the nodes, and the value will be how many steps of probability. And we need to write an DFS to the first DFS. We can call it a Bob DFS, right? Probably it's Y B DFS. And we need to have this kind of map. And we need a current node, right? And the things that for this kind of trees, because it is actually graph, right? So for this graph, we for every child, it may still goes to its parents. So if we goes to for each child trying to see if it is parent, we can continue. So we are going to pass the parent. And in this case, we don't need to use the visited array, right? So pass a parent variable will be one of the technique we can use here. And we can have, what we need is that we need to create this map. So for first DFS is that we have Bob DFS map, and the current is Bob, right? Bob is at Bob's position, and let's see. For every node of this kind of tree, right? We can consider this node as root, right? So for Bob, let's say its parent is -1. And we have Bob map. So this is the first DFS. And we also need to have a path to record those kind of route, the path from 3 to 310, right? So we need to have an integer path which record the Bob's path. As Bob, okay. And let's have this one as a parameter as well. So what we need is that if current equals 0, right, that means it goes to root. Then we need to add for this path from beginning to 0, right, to the map. So what we are going to do is that for int I equals 0, I smaller than path dot size. I plus plus we are going to have Bob map put path with I, and the step, right? Step is I. And actually we can return. So we'll say for in next in map with parent, right? The thing is that well, say if next doesn't equal to parent, right? Because yes, if we go to 1, right? From the map, it still can go to 3, right? So let's say if it doesn't equal parent, then that is it's a child. It will go to these kind of directions. But this one, it will be continued. Then we continue. And we're going to have pass add next, right? And we need to pass remove pass plus size -1. And we have DFS, right? DFS that is map next, and its parent is current and pass and Bob map. Okay, so this is the first DFS, right? Okay, let's try to see whether the first DFS we are able to get it successfully. We can print, right? So map entry. Entry. Bob map going to set now. Let's try to see for the first step if we did it successfully or not. Should add 0, right? So this is at 0. Not fancy should be called a 931, right? So this should call BDFS, right? BDFS, Bob DFS. Okay, so did we print? Didn't see the if next equals parent, not a, this is wrong. Okay. So we'll see. We compose a map which have the nodes probability and the steps Bob used to reach these nodes. Okay. So for the second step, what we need is that we need to do the DFS for Alice, right? So for the Alice, we also need to have a DFS. Let's call it Alice DFS. We want to have its maximum money, right? So we can have result equals 0 into 1, right? And the result 1 equals minus INF, right? So we set this kind of have it final static int INF equals integer dot max value, right? And we are going to have a Alice DFS, right? DFS, and we need the map, right? This kind of map, which is a tree. And also we need the Bob map, which is we compose from the first DFS. And Alice now it is set position 0, right? And its parent is -1, right? Because we also need to, if we traverse its chart, and see whether it is its parent or not. And we need what do we need? We need the steps, right? Alice used steps. So at the beginning, the step is 0, and the money, right? The money Alice used. So at the beginning, Alice is have this money, right? Amount 0. And also, in order to calculate the money in her past, right? We need to pass in this kind of amount array, right? And we'll have a result. In the end, we get the return result. And let's write the second DFS. Private void Alice DFS. So we need to have this map as the tree, and we need to have a Bob map to see if we visit a node which Bob visit or not, right? And we need to have a current position, and then we need to have parent, and we need steps, because to calculate the money, we need to have steps, right? So we'll have current money, and we need a amount, and we need a result, right? So we'll say if map get current, if its size equals 1, right? That means this is leaf. And also I say this is not, and also this time equal to 0, right? Because this is what she stays. Then we are going to have result 0 equals max dot max, right? We want to have max result 0 and money. And also for Alice, it's child, right? For Alice, it's child. It is for int next in map get current, right? So if next equals parent, we're going to continue, right? So let's say add money equals 0. That means for this next child, we are going to add this kind of money to our money, right? We need to calculate this number. So there are several we'll say if Bob map contains it next. If it doesn't contain, that means Bob will not visit this kind of node, or our step +1, right? Because in each child is step +1 smaller than Bob map get next, right? Means Bob get this one, Alice get this node earlier, right? Then add money equals next. Let's say amount next, right? And what we say else if this steps, right? Step +1 equals, right? Equals of map get next, right? That means we need to split add money equals amount next divided by 2, right? And else, that is a step +1 smaller than greater than Bob map get next. That means Bob visited the node earlier, right? So that case add money will be 0, right? Then we're going to have a DFS, Alice DFS map, Bob map, and we are going to have next, right? Its parent is current, and the steps were +1, right? and the money add money, yeah, money and amount in the result, right? And result 0. Okay, 0. Steps, right? Should be steps. Let's comment this kind of print stuff. Okay, the time complexity will be because we are going to traverse every node, right? So it will be O(n) and Charles twice, right? Bubble once and also Alice once.